And we are live. Hello and welcome to episode 2 of GameHammer live game coding. Now, last week we started a text adventure. I hope this microphone isn't too loud. Last week we started a text adventure in Locomotive Basic on the Amstrad CPC. And we're going to continue with that this week. Now, after the end of last week's episode, I did make a couple of cosmetic changes and a few game function changes to the code that we ended with. I've updated the GameHammer website with the information about that, but basically what I've done is I've changed the title screen so it's got a little bit more colour in it, and I finished off the movement code. So how we had north, south, east and west at the end of last episode, we now have northeast, southeast, southwest, northwest, in, out, up and down. It's all the same code that we had before. So let's get straight over to the game. And I believe this will change it. Yes, I am kind of getting used to what goes on here. But we need to actually bring the game code into the machine. So let's load in episode 1. And now you can see we ended at 9k last time, but we were only just under 10k. So now that I've added in that movement code, it's bumped it up to 10k. But that's okay because it's an Amstrad CPC and we are going with 64k of game code at the moment, which means we have 48k to play with. And Patrick's here. Hi Patrick. Last week, you would have seen on screen during the live stream, we had text. We had a text box and it didn't work. That's because I had the wrong code in it. Sorry about that. So this week we've actually got the text for the live chat coming into the live stream so you can see it, which means that anyone who's watching on a smart TV or looking at this later on their phone can actually see the text as we go. Anyway, we've got the game code loaded in, so let's have a quick look at some of it. It's pretty much the same as it was. List 3000 to 4000, I believe that's the code that we need. Yeah, this is the game loop. We've got all the stuff about the various commands you can put in, like up, down, in, out, and all of that. And as you can see, I've added in the game code for southeast and northeast. So let's list 3200 to 3500. And then we have the game code that I extended. So now we have up, down, in, and out, plus all of the secondary compass points, as well as the cardinal ones. So what do we need to do now? Well, the first thing we need to do is run it and make sure that it works. As you can see, I have now got some, basically just a little bit of colour on the screen. It makes it look a little bit nicer. So it now highlights the important parts. Press S to start, or I for instructions. Press I and all of the code is justified on the screen. Well, not justified. All of the code doesn't scroll across lines now. So all of the text is in the right place, basically. It looks alright to me. I hope that looks alright to you. So let's press a key to return to the title screen, and it all works. Press S to start. It is a little slow. It was slow last week as well. There's not much I can do. And I haven't changed any of the various rooms code. So it all still scrolls off the edge of lines. I haven't justified any of that. We'll do that after it's all working. But we can now see if I press D and enter for going down, your character goes down in the ship. Back up again, we go east, and the game is working. We can even go out of the ship, which means we can now walk around, but you can't do much. Because if you remember, last week we had the map, which I should be able to... We have one thing here. So I forgot to bring up the map before we started, and I can't remember where I've put it. So we are going to just have to go with what's on my screen. The map. We have a few in the ship marked as doors that we couldn't get through last time because the ship needs power. And that's the first thing that I want to bring in this week. So let's go back to the game code. Whoa, whoa, whoa. Okay, that wasn't a good thing, was it? Let's move this. I had this all set up nice. And then, I don't know what that was, but who knows? Right, there we are, about right. So, we need to now get out of this mode 2, pen 2, list. Oh, for goodness sake, pen 1, list. So I want to go to mode 2 now. It's smaller in terms of text, but it means I can see more of what's going on. What I need to look at now is to find out where I need to be in this list of data. So we're looking at 400 to, let's say, 600. I need to find out where we put the next thing in what we should have set up before but didn't. So we need to keep looking. 600 to 1000. Apparently I was very close to the end of it. So 600 is where the data stream seems to end for the rooms. And I need to remember that. So list 1000 to 3000. There we are. So the data for... Right. The data for all of the exits starts at 2000 and ends at 2150. So I need to now add in something called flags. And the flags are going to be little markers that the game needs. The game will need to know how to work out whether, for example, the crash ship has power, or whether you have the ability to do something that is required in order to complete the game. That is what we're going to use flags for. So we'll have flag 1 as power, flag 2 as something else. Hi to Yellow Belly and Retro Mickey 82 who have turned up. Hope you're doing well, guys. And Patrick, using BASIC to code your game, yeah, it's going to be... It's not as hard as people think. That was the purpose of doing this live stream, is to make sure that people realise that coding in BASIC for an adventure game isn't that bad. So, anyway, I'm going to put in a new line. We've got 2150 as the final line of the direction code. So, we're going to start at 2500. I think that's going to be enough. So, 2500. Hang on. 300 to 400. I want to see... No. 200 to 300. Yeah. Set up the game variables. We've got run percent, paragraph percent, and things like that. We need to edit line 260. Let's go back to mode 1, so you can actually see it on the screen. Pen 2. No, pen 3. Edit 250. No. Edit 260. I've just got it wrong. So, we've got the run percent, which is how many rums we have. String for paragraphs, exit string. Now we need another thing of flags percent. No. Flag num. I'm going to call it flag num percent. And I'm going to set that at 20. I don't think we'll need 20 flags, but I need to know that we've got enough of them. And then and we also want an array of flags percent, which we will set at flag num. And that gives us our amount of flags. So we know that list 2000 to 3000. That's the exit data. So if we come into 2500 now, we can set that flag set, and I want every single one to be set to 0. So we're just going to use a quick for next loop. For t equals 1 to flag num percent. Oh, give me a second. I've forgotten whether we need a colon on that. It's been a long week, let's put it that way. I need to list quickly to work out, to remind myself. Yes. Yes, we do. So edit 2500. For t equals 1 to flag num percent, I need a colon there. Flags percent t equals 0. Next t. That's all we need. That sets up all of our flags at 0. Every single one in the array will be 0. And if we need to, we can add in extras, or we can reduce the size of that, which will reduce the amount of memory that's taken up as well, which means that now we've got all of our flags at 0. But there is one more thing that we need to edit because we haven't got any objects in the game yet, and we're going to need some objects for the character to be able to pick up, put down, put in the inventory and things like that, and use to solve the game. Because we can walk around all we like, but if our character, the Arbiter, can't do anything, then she won't be able to solve the game. So, we need to go back to number 260 now, don't we? We're getting a bit full there, actually, so that's number 265 is already used. So, we're going to have line number 261. So, let's have dimension, let's call it objects. That's fine, isn't it? Objects. Now here is an interesting thing. This one I'm not going to define the same way I would have defined before. Because I want to be able to let's say, no, we're going to have two things here. We're going to have two we're going to have object string, which is going to have three. We're going to need three variables for object string. We're going to need the name of it, the keyword for it, and the description of it, because we need to be able to examine. So we need to set %, equals, let's say we're going to have 20. We're going to be able to change that later. So dim object string as obj %. Someone is trying to phone me. Oh, for goodness sake. Someone's trying to phone me. Okay, sorry about that. obj %, because we need three different amounts. We need three things, and they need to be the same amount on each one. Do they need to? Yes, because I need to be able to set a name, a keyword, and a description, basically. So, let's have that, but we also need another thing. We need obj POS %. And that will be the same as obj %, because that sets the position of the object. And we need both of those because we need to have one as a number in order to be able to compare it to the ROM numbers, and the other ones are for text. So we have one as a string and one as an integer variable. That's the word I couldn't remember last time. So now we need to be able to go back to the other thing, which was, I believe it was 2,500. So list 2,400 to 3,000. Yes, 2,500 set the flags. So let's have a think. If we start 2510, that should set the data, but I need to make sure that we can do that. So yes, hi Jennifer, hi Roberto 62200 as well. Jennifer, my lovely wife, is in her attic loft train area. It's her train emporium, and she's up there. So please don't bang on the roof, Jen. That's Jen. If you could hear that banging, she's up in the roof. Please don't do that again, Jen. Okay, I need to quickly look at 260 to 300 to make sure I remember how this is all going and how we did it before. Okay, yes. So, 2510 for t equals 1 to object number. Read forgotten what we called it. No, I haven't. Read object string t. That should do it. Yes. Yes. Next t. And then actually we can put in a second one next T. So what we've got here, line 2510, we're doing the same thing we did with the ability to read the data in last time, which is for starting at 1 and going to the end of the number of objects that we've set, read in the keyword, the full name, which is what would be shown in the inventory, or as in you can see X, and the description, and then as a second read command, read the position of that object. So that could be somewhere hidden outside of the game, which I'll show you in a moment, because there are going to be some hidden items, somewhere in your inventory, or in a room in the game. So we've got objects set to 20. I'm going to set it to 2 at 261 so that we can show you how this will work. So if I set that to 2 as an object, then 2520 that we then put in the data. So let's have cube, a cube, it's a cube, and in room, or we start in room 2, so let's put the cube in room 1. 2530 data, sphere, a sphere, it's, we're going to change these later, don't worry, it's a sphere, and we'll put that in room 2. That's all we need for the data plan. So we've now set 2 objects, one is in room 1, one is in room 2, and we've got the code in to read that into memory, but they won't show up. If I type run and go into the game, they won't show up. What have we done wrong here? What have we done wrong? This is, We've done something wrong, and I'm not sure what we've done. So let's have a quick look. List 250 to 300. Okay. We can't have 3, of course we can't. Edit 261, I think I see where it is. We can have 2 things in an array, but not 3. So that's object desk, sent. Yes, we can. What am I talking about? obj%. I'm sure we can have 3. I think I see where it is. We don't need to add an object. We need to... That was supposed to be a comma instead of a colon. So, we try and run that again. There. Now it works. We can have 3 variables within an array. We just can't define arrays using colons. We have to put a comma. So, like I say, we've set 2 objects. The game... What have we done wrong? We can't mix our datas, can we? We can't mix data. Yes, we can mix data. What's wrong? What's going on? We have syntax error. Cube, a cube, it's a cube. What's wrong with that? So, data 1. Try and see if that works. This is what we should... This is where I'm going to have to check the manual. I'm not sure what's gone wrong here. I've mixed numbers and stuff before, haven't I? Sure I have. So a quick look in the manual. Because this has stumped me. I'm not using a full stop in a data statement. They're within the full stop, Patrick, is within the quotation marks. That should be fine. I've always done that before. We've had full stops in the quotations when we were doing the room descriptions. This is where it gets interesting, isn't it? When you find something wrong, because then you learn. Okay, according to the manual, you don't need... hang on. According to the manual, you don't need quotation marks for data statements. But I'm not convinced, because if you wanted to add in any kind of punctuation, you would need quotation marks. So I am thinking that we don't. Okay, let's try this again. Let's try something different. If I take this out and put in 2521 data 1, will that run? Something is wrong in here. Syntax error in 252. What's the syntax error for this? Guys, I am stumped because there's nothing in this that we haven't done before. List 400. See what I mean? We've got full stops and punctuation and commas and all sorts within quotation marks in a data statement just there. So, why doesn't it want it in 2520? List 2510. Because the error isn't in 2520, it's in 2510. And in the second read command, we have read object position percentage. But it's not expecting an object position percentage to be one thing, because object position percentage is an array, not one variable. So if I edit 2510 and add in bracket T, close bracket, and then edit 2520 and put back in that 1, and then 2521, take that out and run, will this work? This is the part of coding that makes me... This is the part of coding that really does irk me at times. There is no reason that I can see that this is wrong, but it is wrong. So I'm reminded of those situations where you see those memes on Facebook and Twitter and things where it says, my code doesn't work, I don't know why. And then the same picture and the second frame, my code works, I don't know why. What have we got wrong? Let's 2500 to 3000. I don't know what we've got wrong. Because we're reading in an object as a string with 3 strings. String, string, string. If I take out the 1 at the end of this, which I don't think I have to, and put it again, 2521 data 1, and run that, does that work? No, that doesn't work either. Could what follows data be case sensitive? I don't see how. I don't see how it's case sensitive because it shouldn't be. We've had Roberto 62200 is saying, could what follows data be case sensitive? But the problem is with that is if I list 400 again, there is the data statement that we've got for the descriptions, and the descriptions work. So I am literally at a loss as to what's wrong here, because it should work. But with Yellow Belly saying, is it because T is a number? But it shouldn't. Again, it shouldn't be, because that's just setting which place in the array it goes into. Oh. I didn't expect to run into a flaw this quick. I am literally stumped. I do not know what is wrong here. List 100 to 250 again. I need to look at the way we've done it before. Right. That's 250 to 300. Okay, how we did it. For t equals 1, to room percentage, read parastring t. I think I might have it. Edit 261. Okay. Dimension object, object number 3. And then object position. So, we're now going to change how this is worked out. Instead of having 3 arrays inside one, sorry, 3 variables inside one array, we're going to have 2 variables. So, we have object string, which there'll be a certain number of those. In this case, we've got it set at 2. Inside those 2, we'll have 3 different things that there can be. So there'll be the the keyword, the description, and the title of the object. And then we still need a separate thing of object position, which means list 2500 to 3000. Okay. We need to edit 2510. Oh my goodness, it's getting warm in here. So, for t equals 1 to object percentage. For tt equals 1 to 3. Read object string ttt. Then read object position next t. Then read object position t next t. So that should mean that they all go into one thing. Run. Hopefully this will work. Unexpected next in 2510. Well, that's a different thing to what we had before. So because I've said it wrong. Next, TT. Run. There we are. Right. I see what we got wrong. We can't have 3 different sets of variables within an array. You can only have 2. 1 or 2 in an array. So we had 3. We were kind of pushing our luck, but I'm going to do it a different way instead, which means it's okay. So, yeah, but we are currently in room number 2 and we can't see any objects. And if I go down into room number 1, we cannot see any objects, and that is because our game loop doesn't look for any. So we need to edit the game loop, which is, according to my notes, which I have over here, the game loop is at 3000. So if we go to 3000 to 3500, here is the game loop. Okay, Right, we've got the list of exits. So we're now going to do, basically, we're going to add in one extra thing. We've got a load of if commands to work out which exits there are. And we're not going to do that this time. So we need to know one thing. Let's 3,000 to 3,050. I need to... We're using current run percentage. So, after it says exits, we want an extra line. 3175 will now go sub. First time we've used go sub in this context. And how long is the... So I need to make a note. 3175. Go sub. You can see code. I need to know how big this listing is. So now we're going to list a load of things, and what I'm basically doing is I'm making a subroutine to find out what is in the current location in terms of objects. So what we're going to do now is run a quick comparison of the current run number compared to where the objects say they are in object position. And if they match, that means that object is in that run. So we'll print that object's long title into a string that will then be printed out to the screen. The same way that we did with the exits thing, where you can go north, south, east, west, and all of that. So, our code for movement. So if I start a thing at 3175, we need to go sub our subroutine. The last code I've got is at 4230, and that's for a lot of the code about movement and things like that. So if I now have a, let's start at 10,000, we shouldn't have a problem. Go sub 10,000. 10,000. Objects in room. So 10,010. For t equals 1 to object percentage. If object position percent t equals current room percentage, then let's say string equals string plus, we haven't, it doesn't matter if we define string before or not. Hi Retro and Lim, hi Late Night Reviews. We're just getting into the main code here. So if the object's position for this current object that we're checking is equal to the current run, then add the title of that, which is object string t 2, because you can have 3, plus something that we want to add before, comma, space, plus that. And that's all we need to do. Next, t. But we haven't done one thing before that. Edit 10, 0, 0, 10, 0. String. We can't use str because that str is a command. I need caffeine and I haven't got any. It's a bit of a problem here. So, let's just put strl. It doesn't really matter what it's called. strl equals, you can also see, comma, space. So strl string equals strl string. Next T. 10020 print strl string return. That's all we need. That is all we need for the objects in RUM code. So let's hope this works. Run. Start. Takes a moment. You can also see nothing. There should be something there. There you are. You can also see a cube. Which means that we've done something wrong with the code for the second object, and we've done something wrong with the looking at what objects are in this RUM code. But the code does work. The cube is there. We can't do anything with it, but the cube is there. So list 10,000 to 10,500. We're just going to overwrite the 10,000 to 20. So if left string strl string 2, then we did this before for taking off commas and things like that, equals comma space then I've forgotten how we did it. I think it's right mid string, then strl string equals mid string. No. We've done this wrong, and it's easier to change it by going to edit 110. What I want to do is take the first comma off. Yeah. If object position t equals current RUM percentage, then and no, because it won't be. Oh. Yeah, it's easier to do it by putting that on the end, isn't it? Object string t plus 2 plus comma space. So now we put the comma on the end. So if we run it again, I'm really trying to work this out on the fly. This is something that I haven't done before. There we are. We see a cube, comma, and now we can use the code that we had before, which makes this an awful lot easier. List 3,000 to 3,500. Let's find where it was before. There we are. 3,160. If right string exits string 2 equals comma space, so we can just use that. Edit 10,020. If no, just leave it as it is. 10015. We'll add it in here. If, and we're actually going to just take it from this code so I don't have problems. Right string strl string, then equals left string strl string len. There we are. What I've just done is the same thing that we did with the exits code. If the end of that string is comma and space, then don't print that bit, just cut that bit off and turn the entire string into 2 characters less and add a full stop on the end. So if we run it now, start. Still nothing in that run because we haven't changed that code yet, but down, We can also see a cube, full stop. Perfect. So, where is our second object? So, if we list again, what was it? 1000 to 2000. Where is our cube data? There it is. So, we've got, and there we are, edit 2530, and take that 2 off. So, 2531, 2, data 2. That's all. It appears to be that we can't mix strings and integers in one data statement, but we can have just stick a data statement on the end, and that's perfectly fine. So we've now got 2 objects. If we run again, and yes, Patrick, we will save in one moment. If we save now, it's still not there, but that one is. So, what have we got wrong? What is wrong with this statement? And I think what it actually is we haven't set the objects high enough. I think it's counting from 0, which is not great because I don't want it to do that. Okay, so let's do a quick thing of list 1000 to 2000. List 100 to 300. Where is the thing where we defined this? I can't remember. I should make more notes. Here we are. Object string equals 2. Edit 261. Object string equals 3. Run. I think it's counting from 0, and that's a bit iffy for us. Data exhausted in 2510. So, what's wrong? I don't know. I really don't. So, let's do what Patrick said. Episode 1. Just save the game as it is. Save the game code. And because we're on an emulator and we have to do this the right way, we save to the hard drive as well, because, well, Java CPC has a nice thing in it. You can load a disk image and make all kinds of changes to that disk image, but if you do not physically save it by going up to the Java CPC menu and saving the disk, any changes you've made to the disk during whatever you were doing won't be saved to your hard drive, so it's a temporary save basically. I have here 2 litres of water with a bit of orange juice in. I'm trying to stay hydrated because, my goodness, the sunlight and the heat here has been intense, which is probably not helping my ability to think about what's going on here. So, if we've exhausted the data by turning the objects up to 3, 261, we took it back down to 2. What is our problem? Yeah. What is our issue where we've got our data? What's the matter? Why isn't it okay? If I change 2531 to data 1 and then run the game, then does that mean that both of these objects will turn up and we've got the numbers wrong? Yeah. The cube and the sphere are now in room 1. So what's wrong? Because room 2 should be where we are. I don't get it. Why is that? If I break out and print current room number, we are in room 2, so it should be there, shouldn't it? But we also have one other thing. You can also see colon and then blank. I don't want that, do I? Do I want that? Do I want to always have you can also see and then nothing on the screen? I'm not sure we do. So, okay, let's go back to the 10,000 to 20,000 because we haven't got that many things. Edit 10,020. What I want to do is not print that if we do, if there's nothing in the room. So if strl string equals, you can also see colon space no, we're going to do what we had the problem of less than or greater than. You can also see that. Then print strl return, else return. That means that what we've done there, if this string is smaller than or bigger than, you can also see colon space, then print the thing because we want to know what's in the room. But if it is equal to that, we don't want you to print anything. So if we run that now, we shouldn't see that code in the first room. Exit, there we are, exits are east and down. So when there's nothing in the room, we won't get a you can also see. But we will when we go down, which is great. That's what we want. Now I just need to know, why isn't this working properly? If I go back to 2000, 3000, where's the code for this? If I edit 2531 and put that object in room 3 and then run it, does that turn up in room 3? Is it just the problem for things being in room 2? Down. Now all we see is a cube. Go back up. Go east into room 3. We have a problem. I think I know how to read. I think I know what's going on here. So, let's go back to right. We're reading 3 things into one thing and then moving on. So, if I edit 2510 and take out the bit where it's telling it to read object position T, just take that out. It won't read any of that now. So if we then remove 2521 and 2531, it won't read any of that. And we're going to leave it there with, so let's jump to 2600 and put in for T equals 1 to object percent read object pos percent T next T. We're doing the entire thing again. So 2610 data 1 2. Basically, I'm just forcing it to read that separately, the positions thing, and hoping that this will mean that it will actually put things into the right place. Run. I want to make sure that the objects are in the right positions. And it's still not doing it. Only the first object is in the right place. Everything else is not there. Objects are getting a bit annoying, aren't they? How could we solve this? What is wrong? Well, we've read it in. We've read all the data in. So let's print object position 2. Where is it? It's in room 2. So the object is in room 2. What's wrong? The object's in room 2. If I print object position 1. It's in run 1. They're in the right places. We didn't need to change any of what we just done. We didn't need to change that. They're in the right place. But it's not coming up. Which means the code's wrong. But the code's right for the first one. So why is it working for one and not for another? List 2,500 to 2,800. List the code again. We have essentially the same code each time. It's got 3 pieces of information going in. So let's list our code for... Okay, it is complicated. Right, we're reading the code name, basically what the person would type if you want to get or drop. We've got the title of it and we've got the description. And we read all 3 of those into each object. And then once that's done, we then read the object position numbers. 1, 2, blah, blah, blah. Everything should be working because it works for the first one properly. And we can check that by print. What have we got it? Where object. We've used a restore, Roberto. There is a restore to make sure everything works. So if I print object percent 1, 3, it should tell us it's a cube. And if I print object percent 2, 3, it should say it's a sphere. It's a sphere. So the code is working for getting the information into it. It's just not getting it right after that. Okay, for t equals 1 to object percent, the object percent is 2. Edit. If I go to plus 3, if I go to object percent plus 1, for t equals 1 to object percent plus 1, and run that, what happens? Still nothing. Still not showing up. It does not want to print the second object. So, if I go back to the data statements and add in a third object, what happens? So, that's 2540. 40 data triangle. A triangle. It's a triangle. And then edit 2610. 1, 2, 3. And where did we set up the variables? For objects, edit 261. Set the number of objects to 3. We now have an object that should be in room 1, room 2, and room 3. Okay, that should be okay, shouldn't it? How many of these are going to turn up? Well, the second one hasn't. The third one hasn't. But the first one has. So if I add it to 261, no, list, where is it? Edit 2610. and set all of these to 1, will they all turn up in the first run? Because if they are, then the code isn't counting properly. Subscript out of range, and now we know where. Are they all there in run 1 now that I've changed the code? A cube, a sphere, a triangle. So, we know that the code for reading the information into the game works. But the code for printing the data onto the screen doesn't. So, let's list 10,000 again to 20,000, and we're going to remove all of this. 10010, 10020. We'll just delete that. We're going to code this again, and we're going to put it on multiple lines to make sure we know what's going on. So 10010, string length equals, you can also see space. Oh, for goodness sake. 10010. String length equals, you can also see 10020. For t equals 1 to object percent 10021. If object position percent t equals current room percent, then string length equals string length strl or whatever plus object string t comma 2, which is the data about, and it's the long title basically, plus comma space 10022. Next, t. So, that should be all we need, isn't it? For I'm going to change it anyway. Edit 10021. I have a horrible feeling that it's because of this if check that we're getting it wrong. Else strl string equals strl string. I'm just going to put that in and see if that changes it. So 10030, and then we can have this little bit here, which is fine. One zero zero 40 if strl string. Actually, why am I? Yeah. List 10,000 to 20,000. Okay. I think what we have as a problem is one thing. Remove 10015. We don't want that in there because that is from the previous attempt at this code. Okay. Yeah. Right. Now we've got as line 10,020 the start of the for next loop. It ends on line 10,022. In the middle is if the object position for this particular object equals the current room, then add the long title of that object to the string, else leave the string as it is. then we have the code to go on. Hopefully this will change the issue and solve it. It's still not doing it. Oh, because everything's still in there. Edit 2610 because that's the data. 1, 2, 3. Run. We thought to change it because it would cause all stuff be in the one place, but at least we looked at it right. You also see a sphere. What the problem was, and it's an oddity, because we had an if check and it said if something then, but we didn't have an else on the end, it wasn't ending that if check and moving the for next loop on by 1 digit. Not an obvious bug, but it is a bit of a faff about in terms of basic code. Basically, we were saying if, then, and then not telling the computer to move on. So if we go east, there's the triangle. And that's all we needed. It works. So, let's save the game before we forget. Episode 1. Now we're up to 11k. It took 11k to sort this out. Right, let's save the disk properly. Oh my... Oh, I am so happy that we worked that out, because that was a tricky one. So, we can't do anything with these objects. We have the code for examining it, but we can't examine it because the computer doesn't understand that. So, that's, yeah. Let's add in some more code. I want 2 commands, examine and look, because we don't have a look command yet. So, let's go back to our game loop, which is at 3000, and let's have a look at the commands that we've got that are in here. Right. They start at 3200. That's this 3200 to 3600. Because there isn't much there. So, they're all the commands that we can have. That's all the movement commands. We haven't got anything else. So, let's have a one of 3280 if a string equals L or a string equals look. Then go to $3020. I believe list 3020. Yep. So we've just added in a look command, which all it should do is reprint the screen description. So if I type in look, yeah, there we are. The look command. Basically, in case you've typed in a load of stuff and the run description's gone off the screen, you want to see it again, the look command now just jumps it back to the start of the game loop, which prints the screen description. Simple. So we've got that in. But the one we want is a bit better than that, because we want to put it after the 10th. Yeah. So we need 3290, which is the next one. If a string equals exam or a string equals examine, then go to 10,000 and 50, 40 even. List 10,040. No. List 10,050. Yeah. 10,050 examine code. And we want to go to there because we're not coming back to that part of the game loop. So we had 3290. We're adding the examine code, and that's 10,050. 60. Okay. We have a command of examine. But what I've just done won't work because all we have is one thing, and it's just examine. But we haven't told it what to examine, and the code can't find that. So we need to go back to the manual, which my cat is standing on. Thank you, Freddykins. My cat is guarding this. I need the left command, don't I? Sorry, this has got a bit weird, hasn't it? I do apologise. Let's have a quick look. Yeah, left string. Okay, edit 3290. If left string, a string, comma, 4 equals exam, or left string, a string, 1, 2, 3, 4, 5, 6, 7, 7 equals examine, then go to 10,500. So now what I'm looking for is, we don't need any of that. I'm getting this wrong because I'm tired. I apologise, guys. All we need is the leftmost part. If the first 4 characters in a string equal exam, go to the examine command, basically. So 10,500 is the examine code, 10060. Now I need to find the way to determine what is in the string, and I need to know where the spaces are. Now here's the thing. I know I originally coded this adventure game in Second Life, and there was a great command in Second Life that would find a space and split a string into 2 strings based on the spaces. Now I need to know how to do that in Locomotive Basic, and I have a horrible feeling that we can't do that. But we can split this into 2. So if left string, a string, comma, 5 equals exam space, then go to, then what I need is to I've got what we can do. We can use the code that we were using for cutting strings short. That's how we'll do it. We'll use the code for cutting strings short when we were looking at the inventory code. List 10,000 to 20,000. Where we have here, if right string 2, then go from the left -2. Yeah, we can do that. We can cut the start off and use a different string. I need to know where the right command is again in the manual. The manual, guys, if you ever code, you need the manual or at least the CPC wiki open. Okay. Extracts characters to the right of and including this position specified in the integer expression from the given string expression. So, the example given is A string equals Amstrad, B string equals the last 3 characters of A string, which because prints as rad. So, what I want to know is, let's say A string equals examine car. B string equals right string. And the length command A string, len A string minus 1, 2, 3, 4, 5, 6, 7, 8. That should work. So this is a quick bit of stuff. Print B string car. So what I've just done there is a quick test, and that won't have affected our code at all, where I've set up B string as A string minus the first 8 characters, which gives me the object name, and that is key. So if we have as the so we have no code in 10060. So if A string, if left string A string comma 5 equals exam space, then B string equals right string A string len A string. And we're going to have to do this for almost every single command that requires any use of anything. A string minus 5. Else B string equals right string A string len A string minus 8. What I've just done there is work out whether the person has typed exam or examine. It also means that if you've typed exam and then 3 extra random letters, or just pressed space 4 times, it will also understand that. But that's by the by. All I've done is essentially work out what they've typed, exam or examine, and then cut that off to create a second string of B string. And that is good for us, because it means that we can now, that B string should be the code name of the variable, of the object even. So 10070, we now need to know whether that object is in the room. So for t equals 1 to opt%, which we've already worked out is the amount of stuff we've got, 10080, if optpos, no, if object t comma 1, because that's the code name of the object, upper string, let's put that into uppercase so that it matches. If upper string object string t1 equals B string, then C% equals T, else end if. That list 10080. Is end if a thing? No, it isn't. List 10080. Yeah, it's not. Okay. I'm trying not to make the same mistake we had before. Old Style Gaming says, wow, this looks complicated. I struggle with Java. This reminds me of the time I typed for 4 hours on my VIC-20 to make a skiing game and got a syntax error. Yeah, it's complicated because I forgot how to do it. It's been a very long day and I've been out in the sunlight a lot. I'm tired. I'm worn out, basically. So my head is not quite working the way that I wanted it to. But what I'm trying to do here is find the code that I need. what line 10,080 says is, if the uppercase version of the code for the code name for the object is equal to what the player has typed in, then take the number of that object and put it into C%. That's all we need. So 10090 next T. 10100 for T equals 1 to opt%, because we have to start this process all over again. 10110 if. Is this going to be a text adventure game? Yes. Yes, it is Old Style Gaming. If now pause. Oh, we don't need to do another for next loop. 10100. Sorry. If object position % equals C%. So object position, because now we've got the object number that we're talking about. If the object equals C% equals current room, or object position, and this is where it's going to get interesting. If the object position of C% equals -1, then print object string C% 3, else end if. 10110 go to, and then we need to go back to, sorry about the creaking, then we need to go back to 3180, which is the line for the what now code. So what we've just done there is, if object position, the current number that we found when we did the check, is equal to the current room, or -1, and -1 is what we're going to use as it's in your inventory, then print the description. But it won't work because I've just realised, edit 10100, we haven't put the percentage on the end of current room, so it won't have the right variable. So run, start. We're in a room with a sphere, so if we exam sphere, take this mention once. Oh, edit. What's wrong with this code? Object string T1. Run it again. This should work. Exam sphere. Okay, D% D dollar equals object string. Jen is banging on the roof. T, 1. If upper string D%, D dollar even. That shouldn't have needed to be done, but I have a feeling that it would. Jen's banging on the roof, not because she's telling us that she's alright, Patrick. She's banging on the roof because she's trying to make a model train. A model railway layout up in her train loft. She's got a channel where she's talking all about this, and it's, if you just search for Jenny Emily, or Jennifer Kirk even, she'll have an entire series about her stuff. So, exam sphere. Syntax error. Okay. syntax error, so something is not right. No, we don't want something between else and end. No. We could just blank. It's a syntax. We could just blank D% because we're going to put something back in it. So. I don't think that'll change anything though. Just blanking out D% because we're going to put something back into it straight away on the next loop. Exam sphere. It's a sphere. You were right, Patrick. The end was wrong. It's a sphere. But that's not what we want because it's in the wrong colour. So, edit 10080. No. Yeah. Then pen 3 print objects, else pen 2. Just so it's got something to do. Run. Start. This should work now. I hope. Exam sphere. It's a sphere. Examine sphere. Exam. Yeah, there we are. So now we've got objects that work. And we're going to check that by going to the other ones. Exam cube. It's a cube. Exam triangle. It's a triangle. There we go. Now we know that the examine code works. But what I want to do is save some memory. So let's go back to 1080. We don't need this bit with dstring. It needs. We're going to put dstring back in here. Object string t, 1, and take d out. Then run. And it doesn't matter that we stick it into the second loop because we don't need it. Just tidies up the code. Exam sphere. It's a sphere. See, we didn't need dstring at all. So, 10080. If we take out all of that and just run again, take out the else bit anyway. Exam sphere. And it's fine. So, now we've got the examine code working. We could set objects anywhere that we want. But like I said, we've got one thing that's being checked. If the location is -1. And for that, the -1 is the inventory. We don't have any code for inventory. If I type I, it says I couldn't go that way. So, let's add in the code for the inventory, because that's the next bit. List 3200 to 4000. Ooh. 3300. That's what we're going to do. If left string a string 3 equals inv, then go to I think it's 10,120 or something like that. List 10,100 to 20,000. Where's it end? Yeah, 10120 rem inventory code. And this is very much like the code we've just done for where the position of the stuff is. So, did I get that right? Yes, 10120, 10120. Okay. list 10,000 to 10,000 fire 200. Where is the object in RAM? Okay. So 130. Okay, let's start. It's the same as objects in RAM. On the STRL this time will be I was carrying 10140, and we're going to do the entire thing again that we had for the first one, for the objects in the room 10141, which means I can copy all of this code except object position is -1 instead of current room. (10142) XT 10150. Take off the trailing commas and add a full stop. 10160. The cat is leaving the room. She's bored. Can't blame her. And the bit where it says you can also see would actually be now I was carrying. But we don't want it to be returned, do we? Edit 10160. Where we've got here return, it will actually be go to 3180 because that is else print I was not carrying anything. So we should now have, I'll save episode 1. File, drives, df0, save, saved. We should now have working inventory code. Run. Start. Inv. I was not carrying anything. Oh. I've just made a massive mistake there because the game will end if you're not carrying anything. 10,000 to 20,000 because I forgot to add at the end of that else command the ability to go back to the game loop. The game will literally just stop. So we have to add on to the end of that print. Go to 3180 and just to save a bit of memory, take the trailing space out. Run. So, start. Takes a moment. We're going to have to do something about that. Inv. I was not carrying anything. What now? There we go. Right. Shall we have that in a different colour? Since we're here. Just to break up the monotony of pink. Edit 10160. Pen 1. We'll put it in blue. Save episode 1. Drives, do not save. Okay. How big is the file now? We're up to 12K. We've added 2K since we started. Run. But that's alright because we've got 48 to play with because it's an Amstrad. So start. We have some nice code. Not carrying anything. But we can't get anything and we can't drop anything. So we now need to change that. Okay. List 3,200 to 3,600. Just to find the where we're up to. Okay, where are we? Yeah. List 10180. Okay. 10170 will be get code. So we add in 3310 if left string a string, comma 4, no, 3 equals get, then go to 10170, which sends us to the code for get. But let's say someone's been a smart aleck. Do we want to add in anything else? Do we want to add in if the code is for acquire? Because we could do that, but I'm not going to. It would be the same way that we did the examine code, essentially. It would have 2 if checks. So if the leftmost part of the inputted code equals get, go to the get code, 10180. Now this is going to be similar to what we've already done with the code for finding out during examine whether the object that we're talking about is in the room. So let's list 10,000 to 20,000 to get that code again. And it goes off the screen. So we want list 10,000 to 10120. Now here's the examine code. So we need to know what this thing is. So 10180. So we need for t equals 1 to object number 90. If upper string, no, we're doing this too quick. We need to take, okay, 10180 needs to be b string equals right string a string, comma, length of that string a string, minus 4, because get is get space. So b string equals right string a string, length minus 4. And then we start the for next loop. For t equals 1 to object percent, which is the length of the number of objects that we have, 10190. If upper string object string t1 equals b string, then c percent equals t. This is essentially the same code that we had for examining. 10200 next t. 10210 if object position or object pos percent c percent equals current room, and that's the only equals that we can have because we can't get things that are already being held. Yeah, let's have it so that we can't get things that are already being held, but we'll have a smart aleck response if there is. If object percent c percent equals -1, print I was already holding that. Bit of a smart aleck response, but why not? And let's have it in a nice colour. Pen 3 print 10220 if opt pos percent c percent equals current room percent, then opt pos percent c percent equals -1. Pen 3 print I took plus object percent c percent comma 2. plus full stop. Right, that should be all we need for that. So 1 0 2 3 0 go to 3180, and that is the code for getting something. Run. Press S to start. Get sphere. Syntax error. Oh. Oh, we've left space. We haven't left space. Run. Right, it's getting late, isn't it? Let's have a look and see what we've got. Okay, get sphere. Yes, Patrick, I do. Get sphere. Syntax error again. So, okay, if then, let's stick an else on the end. Run. Get sphere. I took a sphere. So we've now got a sphere. We can't drop it, but we should be able to examine it. It's a sphere. So let's go down where there wasn't a sphere before and examine sphere. It's a sphere. Why? Because in inventory I was carrying a sphere. Now Yellowbelly's asked an interesting question. If you get the object, then go back to the same room, will it still appear in the room? Let's go up and find out. No, it won't, because the object's position has been changed to -1, which is the inventory. But we can't drop it yet. So, let's go back. We now know it works. Save episode 1. And we're getting somewhere. We are definitely getting somewhere. This game is now taking hold because we have objects that we can move. We can't drop them, but we can pick them up. So list 3,200 to 3,600. And where is our code for drop? We don't have any. List 10. So our next one would be 3320 if left string a string comma 4 equals drop. Then go to 10250. That should be list 10200 to 10300. Yeah, 10240 equals rem drop code. So 10250. So having to go to 10250 is fine, but I want to make sure that we get it to the same place in each 10. So 10240. The get code is very much the same as the drop code. So 10250. This is going to be very quick. B string equals right -5 this time instead of 4 for the length, because drop is drop and a space. Equals. We're just getting the code to make sure we've got the object. Quick, because you're just doing it all in reverse. Exactly, Patrick. We are now just doing all of the object code in reverse. We're going to have the same smart aleck thing. No, Siri, stop talking to me. If greater than -1. So if object position C string equals greater than -1, then pen 3, print, I was not carrying that else. 1920, remove that 10280 because I don't want it on 19. Right, so 10290. If object position C string equals -1, then object position C string equals current room percentage. Pen 3 print, I dropped plus objects else 10300 go to 3180. Save episode 1. File, drive, and save. How big is this? 12K still, we're doing alright. So, we have now got the code for dropping, basically. Get sphere. I took a sphere. Down, drop, sphere. I dropped a sphere, look. A cube, a sphere are now in the room. We now have the ability to move this stuff around. Get cube. Took a cube, up. Let's go and drop it outside. We're outside the ship now. Drop cube. I dropped a cube. Look. There is now a cube outside. We'll go in. West. Down. See the sphere, but no cube. Let's go back outside. East. Out. And the cube is outside. We now have the basis of a game. The only thing that we haven't done is use the flags. It's taken almost 2 hours. But I think we've done alright. So, what I suggest we do now is I'm going to save this. File, drives, div not, save. It is now saved. And the drop code was the easiest to do, Patrick. And the reason that the drop code is the easiest to do is because it's the reverse of the get code. And that's just how these things are. It's very, very easy to screw things up. But at the same time, once you know how you're doing it, it's very easy to reverse that code. So I'm just going to make a copy of the file that we've just been working on. Auto1.zip. And I'm going to make that available online immediately because this is basically the end of today's episode. We've done some great stuff. I think out of all of it, getting the objects to work was what was the most important because we don't have a game without it. So let me just copy this into here. Arbiter 1, episode 2. Copy the Dropbox link. Yeah, all of my stuff is in Dropbox. So I'm just bringing this up. And I'm making a copy available online. Right. If you go to GameHammer.com, sorry, not .com. If you go to GameHammer.co.uk, I'm going to put the link straight into the chat room in a moment. There we are. There we are. That is the link. That's what you need if you want to see today's code and download it. Because we have done almost 2 hours. It's like 1 hour 45 minutes. We've got some interesting stuff. We've set up the flags, which in episode 3 we'll actually start using because the flags are what's going to be needed for the puzzles. But to be able to use the flags, we need to set the objects up. We've got objects working. We can pick things up. We can drop them. We can examine them. We can tell whether they're in the room or not. The important structure of the game is all there now. The only things that are left are... My cat is eating plastic bags. Don't do that, Fred. yeah. The important stuff is there. So, I think it's going quite well. And I hope you do too. I'll see you next week for the next episode. And until then, enjoy fiddling with the code. I'm sure you'll enjoy making your own stuff if you fancy it. Thank you very much for coming along. It has been tiring and, my goodness, mentally taxing, but I hope you have really enjoyed this as much as I have. I look forward to doing these every weekend now, so I hope you do too. Thanks for watching, guys. This has been an interesting and a bit problematic at times live stream, but we've got some good code. See you next time.